Today we are going to discuss esterification. Alcohol and phenols react with carboxylic acid, acid chlorides and acid anhydrides to form ester. Now let's observe the reactions. When aliphatic or aromatic alcohols react with carboxylic acid, it results in the formation of ester and water is removed in the form of byproduct. And this reaction is catalyzed by acid. Now let's see how to get the product of esterification. Let's take the example of methanol and ethanoic acid. When it reacts, it gives an ester and water is removed in the form of byproduct. Now we need to find out the product of this reaction. So let's see how to find out the product of esterification. So first of all, draw the structure of methanol. Methanol is CH3OH. Now draw the structure of ethanoic acid. Ethanoic acid is C double bond OOH. This is carboxylic functional group. And in ethanoic acid there are two carbons. So one carbon is of carbonyl carbon and second carbon will be CH3. Now remove the water molecule. When you remove water molecule, you have to remove hydrogen from alcohol and OH from carboxylic acid. Now draw the structure of ester by combining rest of the molecule. So here you will get CH3O. Now it is bonded to C double bond O. So here C double bond O, CH3. So this is an ester. And water is removed in the form of byproduct. Now let's learn how to name this ester. In this ester, you have to name this as an alkyl and this part as an alkanoate. So here alkyl part contains one carbon. So the name of that ester will be methyl and rest of the alkanoate part contains two carbon. So the rest of the part, alkanoate part will be ethanoate. So the name of this ester will be methyl ethanoate. Alkyl alkanoate. This is the IUPAC name for an ester, alkyl alkanoate. Now come to the next reaction. In this reaction, when aliphatic or aromatic alcohol react with acid anhydride, in presence of acid catalyst, it gives an ester and carboxylic acid is removed in the form of byproduct. Now let's try to understand this reaction as well. Understand what is acid anhydride. Acid anhydride. Acid anhydride is formed by the removal of water molecule from two acid molecules. So let's take the example of ethanoic acid. CH3 C double bond O OH. Now draw the other molecule of ethanoic acid in the reverse order. C double bond O CH3. Now when you remove water from this molecule, so that's how I can remove water from the molecule. Now draw the product by combining rest of the molecule. So here you will get CH3 C double bond O O C double bond O CH3. So this is acid anhydride as it is formed by the acetic acid. This is acetic acid. So this anhydride will be named as acetic anhydride. This is acetic anhydride. And water is removed in the form of byproduct. Now let's try to understand the reaction of alcohol with acetic anhydride. So let's take the example of methanol again. So this is CH3OH. This is methanol. When it reacts with acetic anhydride. So let's draw the structure of acetic anhydride. CH3 C double bond O O C double bond O CH3. CH3. Now when it reacts in presence of acid catalyst. So here you have to break the bond between oxygen and hydrogen, and here you have to break the bond between carbon and oxygen. Now combine this molecule. It will be removed in the form of byproduct. When you combine rest of the molecule, you will get the product of your reaction. So let's draw the structure of your product. CH3O, C double bond O, CH3. So this is an ester. Now you know how to name an ester. So here this is the alkyl part and this is the alkanoate part. So name of this ester will be methyl ethanoate. And draw the structure of byproduct. So here byproduct will be CH3 C double bond O OH. So this is ethanoic acid. This ethanoic acid will be removed in the form of byproduct. Now come to the third reaction. In the third reaction, here aliphatic alcohol or aromatic alcohol when react with acid chloride in presence of pyridine. Pyridine is a base. It gives ester and HCl is removed in the form of byproducts. Now let's try to understand this reaction. So let's take the example of methanol and ethanoyl chloride. Now let's draw the structure of methanol. So CH3OH is the methanol, and ethanoyl chloride, I am going to draw the structure of ethanoyl chloride in the reverse order. So here Cl, and it is bonded to carbonyl carbon, and here it is bonded to CH3 as it contains 2 carbon. Now when you remove hydrogen from the alcohol and chlorine from the ethanoyl chloride, you will get your product. So here you will get the product CH3O C double bond O CH3. So this is methyl ethanoate. So this is methyl ethanoate. And HCl is removed in the form of byproduct. So this is HCl. As acid is produced in the form of byproduct, to neutralize this formed acid, we require a base, which is a pyridine. So that's why pyridine is used here to neutralize the formed acid. Now let's read from the book. The reaction of carboxylic acid and acid anhydride is carried out in presence of a small amount of concentrated sulfuric acid. The reaction is reversible. Therefore, water is removed as soon as it is formed. Learned in chemical equilibrium according to Le-Chatelier principle. When you decrease the concentration of product, equilibrium will shift in the direction where the concentration of product can be increased. So that's why equilibrium will shift in the forward direction to nullify the effect of decrease in concentration. So that's why when you remove the water from the reaction medium, rate of reaction increases in the forward direction. Now let's read from the book. The reaction with acid chloride is carried out in presence of base pyridine, so as to neutralize HCl, which is formed during the reaction. It shifts the equilibrium to the right hand side. So again pyridine does the same thing. By neutralizing the formed HCl, it decreases the concentration of product. That's why it facilitates the reaction in the forward direction. It shifts the equilibrium to the right hand side. The introduction of acetyl group CH3CO group in alcohol or phenol is known as acetylation. Acetylation of salicylic acid produces aspirin, which is an analgesic. Aspirin possesses analgesic, anti-inflammatory and antipyretic properties. Now let's observe the reaction. Here the formation of aspirin is given. Aspirin is formed by the reaction of salicylic acid with acid anhydride. So let's see how this reaction takes place. So let's draw the structure of salicylic acid. This is the benzene ring, and here carboxylic acid group is there, and at ortho position alcohol group is there. So here this is OH. When it react with acetic anhydride, so this is acetic anhydride, CH3 C double bond O, O C double bond O, CH3. This is acetic anhydride. So we know you have to break the bond between oxygen and hydrogen of alcohol and oxygen and carbon bond of acetic anhydride. So this hydrogen will get joined with the carboxylic oxygen, and you have to get the product by joining rest of the molecule. So here you will get, this is the aspirin, this is the salicylic acid part, where C double bond OH group is already there, and here oxygen is there. Now this oxygen will get combined with the carbonyl carbon. So here you have to draw C double bond O, CH3. Now draw the byproduct by combining rest of the molecule. So here you will get CH3 C double bond O, OH. So this is ethanoic acid, will be removed in the form of byproduct. So this is ethanoic acid, will be removed in the form of byproduct, and here you will get aspirin. This is aspirin. As this part is of salicylic acid part, and here we have introduced the acetyl part. This is the acetyl part. This is the acetyl group that we have introduced in salicylic acid. So the name of aspirin is given here acetyl salicylic acid, as we have introduced acetyl group to salicylic acid. So the name of this molecule will be acetyl salicylic acid.